Hey everyone! Have you ever wondered what would happen if you spent just 5 seconds on Venus? Well, buckle up because you're about to find out. First off, let's talk about the environment of Venus. It's often called Earth's sister planet because of its similar size and composition, but that's where the similarities end. Venus is a hellish world with surface temperatures reaching a scorching 475 degrees Celsius. That's hotter than the surface of Mercury, even though Venus is further from the Sun. Now, let's imagine you somehow teleport onto the surface of Venus. The very first thing you'd notice is the pressure. Venus's atmosphere is 90 times thicker than Earth's. It would feel like you're 900 meters underwater. The crushing pressure would be instantly fatal. But let's say for science, you're in a super advanced suit that can withstand the pressure. The heat would be your next enemy. At 475 degrees Celsius, you'd be cooked alive in less than a second. Even the toughest materials we have on Earth would melt. Then there's the atmosphere. Venus's clouds are made up of sulfuric acid. Imagine inhaling acid. Your lungs would be destroyed almost instantly. Oh, and don't forget the winds. At the surface, they're relatively slow, but higher up, they reach speeds of up to 360 kilometers per hour. That's faster than the strongest hurricanes on Earth. Alright, so 5 seconds on Venus sounds like a nightmare, right? But there's a silver lining. Venus has fascinated scientists for decades. Understanding Venus helps us learn more about our own planet. It teaches us about climate, atmospheric evolution, and even the potential for life on other planets. So, while spending 5 seconds on Venus would be catastrophic, studying it from afar is incredibly valuable. It reminds us of the importance of science and exploration. Thanks for watching. If you enjoyed this video, don't forget to like and subscribe for more mind-blowing science content. See you next time. Welcome back. Now that we've survived our hypothetical 5 seconds on Venus, let's delve deeper into what makes Venus's atmosphere so unique and deadly. Venus's atmosphere is incredibly dense, composed mainly of carbon dioxide, which makes up about 96.5% of it. This thick blanket of CO2 traps heat through an intense greenhouse effect, causing the extreme surface temperatures we talked about. But that's not all. Venus is also shrouded in thick clouds of sulfuric acid. These clouds reflect sunlight, making Venus the brightest planet in our night sky. Yet they also contribute to its hellish surface conditions. One of the most fascinating aspects of Venus's atmosphere is its super-rotational winds. These winds can reach speeds of up to 360 kilometers per hour in the upper atmosphere, circling the planet in just 4 Earth days. Compare that to Venus's slow rotation period of 243 Earth days, and you can see just how extreme these winds are. The greenhouse effect on Venus is a powerful reminder of the impact of atmospheric composition on a planet's climate. The dense CO2 atmosphere traps heat so effectively that Venus is hotter than Mercury, despite being further from the Sun. This runaway greenhouse effect serves as a stark warning about the potential consequences of unchecked greenhouse gas emissions on Earth. Understanding the dynamics of Venus's atmosphere not only helps us learn more about our own planet's climate, but also aids in the search for life on other planets. By studying Venus, scientists can develop models to predict atmospheric conditions on exoplanets, broadening our understanding of the universe. So, while Venus remains a hostile environment for human exploration, its atmosphere continues to be a source of scientific intrigue and discovery. Thanks for joining us on this atmospheric adventure. If you enjoyed this deep dive into Venus, don't forget to like, subscribe, and hit the bell icon for more fascinating science content. Until next time, keep exploring. Welcome back. Now that we've explored the atmospheric inferno of Venus, let's turn our attention to its surface. Venus's surface is a volcanic landscape with vast plains, highland regions, and thousands of volcanoes. This chapter will delve into the geological features of Venus, including its volcanic activity, tectonic movements, and the mysterious tesserae regions. First, let's talk about the volcanoes. Venus boasts more volcanoes than any other planet in the solar system, with estimates ranging from hundreds to thousands. These volcanoes come in various shapes and sizes, from massive shield volcanoes to smaller dome-shaped ones. Some of these volcanic structures are so large that they rival the biggest volcanoes on Earth. But it's not just the sheer number of volcanoes that makes Venus's surface fascinating. The planet also experiences intense volcanic activity. Lava flows have shaped much of the landscape, creating vast plains and smooth surfaces. These flows can stretch for hundreds of kilometers, painting a picture of a planet in constant geological flux. Next, let's explore the tectonic movements on Venus. Unlike Earth, Venus doesn't have plate tectonics as we know them. Instead, its surface is shaped by a process called flake tectonics. This involves the planet's crust breaking into pieces that move and jostle against each other, creating features like rift valleys and mountain ranges. This tectonic activity contributes to the planet's ever-changing landscape, making it a dynamic and volatile world. One of the most intriguing features of Venus's surface is the tesserae regions. These areas are characterized by complex, intersecting ridges and valleys, giving them a unique tessellated appearance. Scientists believe that tesserae could be some of the oldest surfaces on Venus, providing valuable clues about the planet's geological history. Studying these regions helps researchers understand the processes that have shaped Venus over billions of years. The volcanic and tectonic activities on Venus offer a glimpse into the planet's fiery past and present. While Venus remains inhospitable for human exploration, its geological features continue to captivate scientists and space enthusiasts alike. By studying Venus, we not only learn more about our neighboring planet but also gain insights into the geological processes that can occur on other celestial bodies. Thank you for joining us on this journey through Venus's volcanic landscape. If you enjoyed this exploration, don't forget to like, subscribe, and hit the bell icon for more exciting science content. Until next time, keep exploring. Despite its harsh conditions, Venus has been a target for exploration since the early days of space travel. This chapter will cover the history of Venus exploration, from the first flybys and landers, to the latest missions and future plans for studying this enigmatic planet. The journey to Venus began with the Soviet Union's Venera program in the 1960s. Venera 1 was the first spacecraft to attempt a flyby, though contact was lost before it reached Venus. However, subsequent missions like Venera 7 made significant strides, becoming the first spacecraft to transmit data from the surface of another planet. In the 1970s and 80s, NASA joined the quest with the Pioneer Venus project. Pioneer Venus 1 orbited the planet, mapping its surface and studying its atmosphere. Pioneer Venus 2, on the other hand, deployed multiple probes that descended into the thick Venusian clouds, providing invaluable data. The Magellan mission in the early 1990s marked another milestone. Using radar mapping, Magellan unveiled detailed images of Venus's surface, revealing its volcanic landscape and tectonic features. This mission greatly enhanced our understanding of the planet's geology. In recent years, the European Space Agency's Venus Express orbiter and Japan's Akatsuki probe have continued to study Venus's atmosphere and weather patterns. These missions have provided new insights into the planet's climate dynamics and offered clues about its mysterious super-rotating atmosphere. Looking to the future, NASA's upcoming missions, Da Vinci Plus and Veritas, aim to delve even deeper into Venus's secrets. Da Vinci Plus will analyze the composition of Venus's atmosphere, while Veritas will create high-resolution maps of the planet's surface. These missions promise to revolutionize our understanding of Venus and its geological history. The exploration of Venus has been a challenging but rewarding endeavor. Each mission has brought us closer to unlocking the mysteries of this scorching world. As we continue to learn from past missions and prepare for future ones, the allure of Venus remains as strong as ever. Thank you for joining us on this historical journey through Venus exploration. If you enjoyed this exploration, don't forget to like, subscribe, and hit the bell icon for more exciting science content. Until next time, keep exploring the cosmos.